Nakikita niyo ba yung screen? Do you see my screen now?
Yes po, sir.
Okay. So we're going to solve this problem. Kasi I think may similar problem na nandoon sa problem set na ibibigay ko sa inyo. Kaya isosolve natin to. So you have a guide kung paano sasagutan yan somehow. Okay? So here we have the polynomial x to the fourth plus x plus 1, and we are going to prove that it is irreducible. So meaning to say this doesn't have a non-trivial factorization, no, over z sub 2. And then we're going to use this fact and use a mod p test to prove that the following polynomial is irreducible over the rationals. Okay, so let's see. Yeah, ito mismo yung nasa exam na pinagkuhanan ko. And we will see how can we solve that. So first, my first part, itong prove that the polynomial is irreducible over z sub 2. So di ba kapag, first of all, notice that the degree of the polynomial is 4 because the degree is 4 and 4 already exceeds. Can you please mute your microphones if not in use? Yan. Dahil ang degree nito ay 4 at higit na yun sa 3, no? Hindi natin magagamit yung fact na kapag walang root, irreducible. No? Kasi yung idea na kapag walang root ay irreducible, nag-a-apply lang for polynomials of degree 3 and 2. Kasi you can see, no? You can see that dalawa lang naman ang elements ng z sub 2, no? 0 or 1. By the way, kung tatawagin kong f of x yung x to the fourth plus x plus 1, then as you can see, if I evaluate f at 0, I think I should put it here. If I evaluate f of 0, 0 to the fourth plus 0 plus 1 is 1. And not only that, if I evaluate at 1, you get 1 plus 1 plus 1 in z sub 2 is also 1. So it's not 0. So this only shows, no, that yung by the factor theorem, no, this only shows that this polynomial or f of x, let's just write f of x. Ang tanging mako-conclude lang natin is that it does not have a linear factor. Okay. This is the only thing that we can conclude for now. It is because wala siyang root, kasi kung nagkaroon ng root, by the factor theorem, it will have a linear factor. But it doesn't have a root over z sub 2. No? So it doesn't have a linear factor. Let me emphasize here that we are speaking over z sub 2. But the fact na wala siyang linear factor does not automatically mean na wala nang factors. Kasi pwedeng dahil ito'y degree 4, pwede kasing dalawang quadratic na irreducible. No? That's a possibility. No? So, in order to show that f of x is irreducible, no, we further need to show, no? We further show that that fx can't have an irreducible quadratic factor. But take note that because we are working with the field z sub 2, pwede nating ilista lahat ng mga possible quadratic factors. No? Right. Note that the possible quadratic polynomials over z sub 2 R. Okay. So ano yung mga possible polynomials of degree 2, no? Na o meron tayo over C sub 2. So syempre kung over C sub 2, that nag-start yan sa x squared. Hindi pa pwedeng 0 ang coefficient ng x squared, no? So what are those? Well, pwedeng x squared, no? Pwedeng x squared plus 1. Pwedeng x squared plus x, no? What else? Pwedeng x squared plus x plus 1. Yan lang ang mga possibility. Meron ba ibang possibility na nakaligtaan si sir? X squared plus 1, x squared plus x squared plus x plus 1. Did I forget anything? Meron ba nakaligtaan si sir na factor? Ay, na possible quadratic polynomial. Remember, 0 or 1 lang ang possibility. Sige nga. Meron pa bang nakalimutan? Ano pa yung mga possibilities for a quadratic polynomial? Is this list complete? Can you please confirm? Pakitype nyo complete kung nabanggit ko na lahat. Nabanggit na ba lahat? Not yet? Yes? Ano? Isa-isahin nyo lang. Kasi di ba kapag quadratic polynomial, ganyan. Eh, ang ABC mo dito, ang pagpipilian mo lang, 0 or 1. Diba? 0 or 1. Ito lang ba yung mga tanging combination? So, syempre, by default, si A, 1 na. Hindi pa pwedeng mag-0 yan. Ang pagpapalit-palitin mo lang si B at si C. At dahil may dalawang choices for B, may dalawang choices for C, by counting principle, there are 4 choices. So, may 4 na polynomials lang of degree 2. And dahil 4 na yung nailista ko, so I think this is already complete. Tama ba, si sir? Do you agree? Do you agree? Okay. Well, the problem, you see, the problem with x squared is that x squared is x times x. It's a product of 2 linear factors. On the other hand, yung x squared plus x is x times x plus 1. It's a product of 2 linear factors as well. In fact, over z sub 2, si x squared plus 1 is also a product of 2 linear factors. Mukhang hindi. Kasi sa normal na algebra, over the reals, hindi na factor. Pero alam nyo, over z sub 2, ito ay na-factor. Kasi meron tayong freshman stream theorem. Diba? So it's a product of 2 linear factors. So ibig sabihin, what I'm saying is that this can be a factor of f of x. You know why? You know why? In fact, ito rin. Wait, kakopy ko lang to. Copy. Paste. Ito rin. I know that this can be a factor of f of x. Kasi may mga linear factor sila. Kung isa dito, let's say ito, naging factor siya nung f of x, o di ibig sabihin magkakaroon ng linear factor to. But we have verified that this doesn't have a linear factor by the, what do you call that? What do you call this? Factor theorem. So ito na lang, ang titignan natin. Ito ba yung na-factor into linear factors? As you can see, this also has no root in C sub 2. You can verify once again. Tignan nyo, 1 plus 1 plus 1, 1. 0 plus 0 plus 1, 1. Never nag-0. So it has no root in C sub 2. Hence, has no linear factor. So, check natin ngayon if x squared plus, the question is this a factor of f of x? Yung mga pula, ano yan ha? Ito yung mga bagay na tumatakbo sa isip ko. So you can see. Na? Is this a factor of f of x then? How would you know? Now, I think at this point, wala tayong ibang method na alam but to actually use long division. Kailangan kung factor yan, dapat ang remainder ay 0. Let's see. Let's apply long division. Applying long division. Paano yung long division? This is x to the fourth plus 0x cubed plus 0x squared. Nilalagay ko ng 0 ha para di ba ganun ang long division? You have to place. So anong ginagawa ko dito? Ba't ako nagla-long divide? I am checking if x squared plus x plus 1 is really a factor of f of x. Kasi if so, anong mangyayari? Magiging reducible. Pero remember, ang goal natin is to show that this is irreducible. So dapat ang sagot dito, negative, na dapat may remainder na hindi zero. So how do you know the remainder? Walang ibang paraan at this time. Hindi ka naman pwedeng mag-synthetic division kasi hindi to linear. No? But to use long division. So x squared, x to the fourth over x squared is x squared. Then x to the fourth plus x cubed plus x squared. Diba ganyan siya? Right? And sa subtract. Wala to. 0 minus 1, negative 1. Kaya lang sa z sub 2, ang negative 1 ay 1 din. Kasi ang 1 plus 1 ay 0. So, lalagay ko lang dito x cubed. Again, 0 minus 1 is also 1. Kasi negative 1 sa z sub 2 is also 1. Kaya x squared ito. Baba ka ng isa. Kailangan magkasing dami yung term sila. Then you divide x cubed over x squared. You get an x. You get x cubed plus x squared plus x.
Sir, di po negative x cubed plus minus x squared plus x.
No? What?
Yung dun, dyan po sir, maging negative x cubed minus x squared.
Okay. Negative x cubed, ganyan ba yung sabihin mo? Negative x cubed minus x squared, ganyan?
Yes po sir.
Oo. Kasi kapag tayo nasa z sub 2, ang negative x cubed parehas lang sa x cubed. Kasi yung negative 1 parehas lang sa 1.
Thank you po sir.
Kaya sinulat ko na lang na pwede nyo rin naman isulat negative 1. Kaya lang ako I just stick to the convention na laging 0 or 1 lang. Pero pwede rin naman iwanan yung negative 1 dyan. Okay? So itong nangyari. Ang ginawa ko, ganyan. What happened? So di-divide ko. X cubed over x squared x. Tapos, bakit parang nagiging divisible? Wait lang. X cubed plus x squared plus x. Hindi. Ayun. Pag kasi sinubtract ko to, syempre 0 ang lalabas, no? May isa ka pa palang 1 doon, ayun, no? May bababa ka pang 1. That's it. Ang degree naman nito nga ngayon, 0 na. At ang 0 ay mas maliit na sa degree na 2. Di ba? So, the idea is that the remainder is 1. And it's not 0. So, this means that x squared plus x plus 1 is not a factor of what? Of f of x. Kasi if it was a factor, di sana ang remainder ay 0. So nakita nyo, this can be a factor. This can be a factor. This can be a factor. By long division, this also can't be a factor. What is the conclusion? What is the conclusion? Anybody? The conclusion is that, ako rin ang sumagot eh, no? Walang linear, walang quadratic factor. So, actually, yun yung conclusion ko at this time. Walang quadratic factor. So, I think let me erase this delete. Okay. The conclusion is that f of x does not have a quadratic factor as well. It follows that f of x does not have a cubic factor as well. Alam nyo bakit? Why? Bakit mag-follow na ito by default? Sige nga, I want to write anybody who could explain bakit hindi na natin kailangang i-prove ito and why does this follow? Okay, nag-start tayo by proving that it does not have a linear factor, then it does not have a quadratic factor. Kasi nilista natin yung isa-isa yung mga possible quadratic factors. Yet none of them was a factor, no? Bakit hindi ko na kailangang ipakita na bakit mag-follow na automatic na walang cubic factor? Who would like to explain, please?
Ano sir,
Aside,
yes po.
Irene, okay.
Kung may cubic factor, kung kaya po nagpo-follow na wala ng
Okay.
cubic factor kasi kung meron po, ibig sabihin meron po tayong linear factor.
Yes, okay. Then very good. Kasi kung si f of x has a cubic factor, the other factor must be linear, which will contradict the first the first claim, 'di ba? Sabi natin kasi kanina, wala siyang linear factor. Lagay ko dito na ang paliwanag, otherwise fx has a linear factor, which is not. So wala kang linear, walang quadratic, walang cubic. So, conclusion. Therefore, tapos na. F of x, which is x to the fourth plus x plus 1 is irreducible over z sub 2. Okay, so that's the first claim. Now, the second part leads you to using a mod p test. So naturally, ano kayang p ang kukunin mo? So naturally, kukunin mong p ay 2 kasi ito yung ito yung alam mong irreducible. Maybe kaya yan binigay kasi gagamitin mo ito. Na? So first of all, i-reduce mo muna ito. Kaya lang, tingnan nyo. Now, lagay ko dito ha. Now, let g of x be the polynomial 1/2 x fourth 5/3 x cubed minus 2/3 x squared plus 7/6, ang hirap comprehend, plus 3/2. Then as you can see, if I multiply a 6, bakit 6 ang naisip kong i-multiply? Bakit 6 ang naisip kong i-multiply? Kasi yun yung LCD ng mga denominators. The reason for multiplying a 6 is to transform the polynomial into an integer polynomial so that we have 3x to the fourth plus 10x cubed minus 4x squared plus 7x plus 9 if I'm not mistaken. Right? Did I do it correctly? So, ang idea kasi, yung 6 naman na yan ay unit. Unit lang siya ng unit lang siya ng Q. So, kumbaga, kung ilalagay ko siya dito sa kanan, may times 1/6 ako. Di ba? Sabihin yung g of x is 1/6 times this integer polynomial. So, kumbaga, dahil unit ito, unit, wala siyang bilang. Hindi natin siya binibilang as a factor. So, kung mapapakita natin ito ay irreducible, it's the same as saying that g of x is irreducible. Diba? So, let me just write here that g of x is irreducible over q if and only if the integer polynomial this is irreducible over z sub p for over z. Ganyan muna. Yan. Wala muna tayong c sub p. And then, this is the time, dahil integers na yung mga coefficients, this is now the time to use the mod p test. Let p be 2. Actually, ang gagawin ko, yung 3x to the 4th plus 10x cubed minus 4x squared plus 7x plus 9, i-reduce ko yan modulo 2. As you can see, kapag modulo 2, yung mga odd nagiging 1, yung mga even nagiging 0. So, when this reduces, ano mangyayari? X to the 4th plus x plus 1, which is a familiar polynomial. This is in C2 square bracket x. No? Note that yung degree nung reduced, no, it does not change, no? Ang degree nito 4 at ang degree nito ay 4 din. Hindi nagbago yung degree. So, by mod p test, yung mod p test is applicable. By mod, actually, p test where p is 2, anong conclusion? Yung 3x to the 4th plus 10x cubed minus 4x squared plus 7x plus 9 is irreducible over z, therefore, irreducible over q. Diba naalala nyo, last meeting, pag irreducible ka na over z, automatic, yan ay irreducible over q. Therefore, g of x, the original polynomial is irreducible over q. So, ganyan. Nakuha nyo? So, ito yung aking solution sa exam problem na ito. So, again, balikan natin. Dahil kasi ito yung degree 4, hindi na nag-a-apply yung just check for linear factors. No? That doesn't apply anymore. Kung wala siyang, kasi normally kapag degree 3 or 2, wala ka nakitang root doon sa field, no? Automatic, pwede mo nang i-conclude, ay, irreducible yan. Finish na. Pero kapag degree 4 pataas, hindi yun nagpa-follow. Kasi posible naman na meron pang quadratic factor, merong cubic factors, etc. Were you able to follow my solution? I want you to study this kasi may parang ganito dun sa exam na sagutan nyo. Parang may question very much parallel to this. Medyo iniba lang yung given. Okay? So, ang tanong, bakit ba tayo G na G malaman kailan irreducible ang polynomial over a field? May sagot tayo. So normally, kapag irreducible ang polynomial, tapos ang degree niya 2 or pataas, that implies na yung polynomial ay walang root. Kasi kung degree 2 pataas ka at irreducible, walang root, walang linear factor kasi. Naintindihan nyo? So therefore, mawawala ng root ang polynomial. Pag walang root ang polynomial, that's sad. No? It turns out that kung irreducible ka, no, meron tayong magagawa. You will see. Nakita ko na sa inyo to. This is the direction we are going to. We will show that if f of x is irreducible over a field f, no, when you look at the ideal that will be generated by f of x, again, ang laman nito are the polynomial multiples of f of x. Lahat ng mga polynomials na divisible sa f of x. We will show that because this is irreducible, we will show that this ideal is going to be a maximal ideal. Pag sinabing maximal ideal ulit, ito yung f of x, f square bracket x, ito yung I mo. Pag sinabing maximal ideal ito, wala kang makikitang ideal na nasa gitna nila. No ideal is intermediate. No? Yun yung ating terminology. Wala kang makikitang intermediate ideal na nasa gitna ng I tsaka ng f square bracket x. Now, so what kung maximal ideal yan? Meron kasi tayong theorem from last time. Pag maximal ideal yung I, no, in f square bracket x, actually in any ring, the quotient ring that you are going to form is going to be a field. Okay? So, ito yung sinasabi ko kanina. Kung sakaling ang degree nito ay greater than 1, that means to say that f of x has no root. We will show that using this field, no? We will show that there exists a field E containing a subfield isomorphic to f such that f of x has a root in E. Palagay nyo sino tong E na sinasabi dito. Actually, yung E ito. No? Yung E na yan, ito si F, no? Kukonstructin natin yung F square bracket X modulo I. Tatawagin ko itong E. Ngayon, yung E na yan, ang laman nito mga cosets, di ba, ng I. Weird, no? Sa ring na ito or sa field na ito, actually, merong element dyan na alpha. May isang coset dyan, tawagin yung alpha. Kung saan, yung alpha na yun ay root nung f of x na kanina walang root. Tapos, at the same time, meron tong subfield na tatawagin natin f prime. Tapos yung f prime na yan, isomorphic doon sa f. So, parang somehow sinasabi natin na kapag walang root yung f of x sa big F, no? So, pwede mo actually, kasi isomorphic ito di ba? So, kung ito may katapat doon, maybe ito ay may katapat dito. No? So, parang sinasabi natin, a field can always be extended upwards, no? So that what? So that the extension will now contain a root for the given polynomial kanina na walang root. So this is what we're going to achieve after this lesson. Papakita muna tayo dun sa step 1. Yung step 1 muna tayo. Okay? Were you able to follow? Sundan nyo ha? Nakakasunod pa ba? Nakakasunod? Ito yung magiging flow ng ating discussion. Step 1. The first step is to show that if you have an irreducible polynomial over f, no, then as an ideal, if you're going to generate all the polynomial multiples of f of x, it will be a maximal ideal of f square bracket x. And actually, this is an if and only if statement. So meaning to say, kung ito ay maximal ideal ng f square bracket x, pagka-follow din na yung generator niya na f of x is going to be an irreducible one. Parang if and only if kasi siya. All right. So in other words, maximal ideal, principal idea, paano ba to? Yung mga principal ideals na maximal dito sa f square bracket x are always generated by irreducible polynomials kasi if and only if siya. So let's first go in this direction. So here our assumption is that f of x is irreducible over f of x over capital F. So meaning to say this cannot be reduced any further. So ano mapapakita natin? We will show that this is a maximal ideal. So the idea is this. Kunwari, merong ideal sa pagitan ng I tsaka ng f square bracket x. Pero wala naman ako sinasabi na yung j na to is different from I or si j ay different from f square bracket x. So actually, in my mind, by the way, in my mind, what I wanted to show, no? In my mind, this is what I wanted to show. To show that I is maximal, what do I wanted to show? I wanted to show that j is either I or j is either f square bracket x. Kasi pag yan ang nangyari, para mong sinasabing walang iba na nasa gitna ng I tsaka ng fx. Kasi kung meron mang ideal, it's either I or f square bracket x. So that's what I wanted to achieve. Okay. Now, kapag kumuha ko ng ideal ng f square bracket x, now this is from a previous lesson. Sabi natin dati, lahat ng ideals na ito are normally generated by a single polynomial. So kunwari yung J na yan is generated by P of X for some polynomial. Kunwari yan, P of X yung generator ni J. Anong mangyayari? Kasi pag ang F square bracket X, sorry. Nas na ba ako? Narito ako. Anong ibig sabihin nito? Ba't nagkaroon ng F of X is in J? Parang may nawawala dito. Okay. May nawala nga dito kasi I don't normally start my sentences with symbol. So that's a hint na meron ako nakalimutan dyan. Kasi I don't, actually, ito'y advice ko sa inyo when you are writing mathematical sentences or proofs, no? You don't normally start a sentence with a symbol. You start with a word, no, an actual word. So ganito. The idea is here. Si I kasi, di ba, generated by f of x. Tapos by assumption si I nasa loob ng J. Right? So ibig sabihin nito, si f of x mismo ay nasa I. Kasi generate niya yung I. Si I subset ng J. So that means si f of x ay nasa J. At kapag ikaw ay nasa J, ang mga polynomials na nasa J are multiples of P of X. So therefore, I can write f of X as a product of P of X with something else. That's what I mean by the second, by this part. Intindihan nyo? Kasi nga, laman ng J, mga multiples ng P of X, so it's of the form P of X times some Q of X. Sabi nga natin, si f of x irreducible over f. So, kung meron mang factorization na ganito, anong katotohanan? Dapat yung isa dito ay unit. Diba? Ano bang units ng f? Diba ang units ng f? Yung mga non-zero constant. So, therefore, isa dito sa p of x or sa q of x ay non-zero constant. Correct. Either yun. So, cases tayo. If P of X is the one that is the unit, no? Kung ito yung unit mo, kung ito unit, non-zero constant siya, mag-follow na yung J mo magkakaroon ng unit. Did you remember? Sabi ko kapag ang ideal has a unit in it, automatic siya yung entire ring. Walang ibang ideal ang isang ring na mayroong unit maliban doon sa ring itself. Lahat ng mga ideals na mas maliit doon sa ring should never contain a unit. That's a property from a lesson way back when we were talking about ideals for the first time. Sige, you can kind of review. Kaya mangyayari, kung si P of X yung constant, yung J magkakaroon ng unit. So si J ay F square bracket X lang. Kung si Q of X naman ang constant, anong mangyayari? Kung si Q of X ay constant, ibig sabihin nito, what does that mean? Kung si Q of X ay constant, ibig sabihin, yung F of X is P of X times a constant. That means to say, what? Yung ma-generate ni F of X ay ma-generate lang din ni P of X. Parehas lang sila ma-generate kasi they only differ by a factor of a constant, which is a unit 1. Therefore, parehas yung I tsaka yung J. Kaya nga ano nangyari? Kung kumuha ka ng J sa gitna ng I tsaka ng F square bracket X, dalawa lang ang possibility. Either J is I or J is F square bracket X. What does that prove? It proves that I is a maximal ideal. So we were able to prove this direction. On the other hand, no, if we now assume that this I, is a maximal ideal in F square bracket X, how do we now show that the generator f of x is irreducible? First of all, kung si f of x ay generator ng isang ideal na maximal, it cannot be zero. No, it cannot be zero. At hindi siya pwedeng maging unit. Otherwise, kung unit ito, yung I mo magiging equal lang sa f square bracket x. You don't want that. No? Suppose, how do we show that it's irreducible? Kunwari mafa-factor mo siya into 2. We will show that one of these factors must be a unit. Okay, that's the idea. First of all, ganito. Kung si f of x ay multiple lang ng p of x, ibig sabihin yan, lahat ng multiple ng f of x ay multiple lang din ng p of x. Kasi kapag multiply ka dito ng kahit na ano, mamumultiply lang din siya dito sa kanan. So basically, lahat ng divisible sa f of x magiging divisible din sa p of x. Kaya yung I mo, containing all the multiples of f of x, should be contained in the set of all multiples of p of x. So this is another ideal that falls between this and this. Kaso anong klaseng ideal si I? Maximal. So hindi pa pwedeng yung ideal na J ay different from both of these. Kailangan yung J equal doon sa I or sa F square bracket X. So therefore, either ito equal siya dito sa I, so itong mangyari, or yung ideal na yan equal sa F square bracket X. Tingnan natin. Kung itong first case ang mangyayari, kung parehas daw ng multiple si P of X at si F of X, ano mangyayari? First of all, dapat ang degree nila ay parehas. No? Hindi pa pwedeng iba. So, ano nangyari dito? Meron ka ditong factorization. Parehas ang degree ng F of X tsaka ng ganito. Look at this equation. Naka-underline. Parehas daw ang degree ni P tsaka ni F. Anong totoo about Q? Q of X must be degree 0. In fact, it has to be a non-zero constant. Therefore, a unit. So, magiging unit yung Q of X. Okay? Now, when you look at the second case, kung ito naman ang true, kung ma-generate, kung lahat naman ng polynomials ay multiple ng P of X, anong mangyayari? Magka-follow na si P of X ay non-zero constant kasi hindi pa pwedeng lahat ng polynomial multiple ng kahit na sinong polynomial. The only thing that can do that are the non-zero constant, which is a unit. Kaya nga dalawang possibility. Kung ito ay equal, dapat either Q of X is a unit or P of X is a unit. So therefore, F of X must be irreducible. Kasi kapag fa-factor mo siya, the only possibility is unit yung isa. Did you understand? Okay? So it doesn't matter kung, let's say, iniisip niyo, paano kaya naisip ni sir yung mga proof niya? The truth is, you don't really need to, let's say, feel bad kung hindi ko naisip na gawin yan. No? I mean, ang goal naman is not for you to, okay lang kung, let's say, isipin nyo, ay hindi ko kayang gawin yan mag-isa. That's expected kasi these are main results in abstract algebra that are so important na, of course, yung mga proofs nila are not so obvious. Expected yun. Ang importante dito, nauunawaan nyo yung pagkakasunod-sunod, why does this is being implied, no? That's what's important kapag magbabasa tayo ng theorem. Ang mahalaga dito, alam nyo kung kailan to i-apply, no? On specific cases, no? Paano siya ina-apply, kailan siya applicable, kailan hindi. Ayun, ganun ang mahalaga. Pero kung you feel bad kasi I think I cannot do the proof. Most likely, and most of the mathematicians can prove everything, no, at one. Kasi iba ang pagbabasa ng proof sa pag-discover ng proof, no. Normally, discovery of proofs like this, no, takes time. Hindi siya madali. And to be able to do this alone, no, it will need or it will require experience in mathematics. Bakit ako kabisado ko? Hindi ko siya technically kabisado, no? Hindi ko siya technically kabisado, pero parang because of experience, kapag itong linya na to ang nakita ko, ay alam ko na kusunod. Parang based on experience. Okay. Let's just recall. If you have an ideal I of a commutative ring R with unity, kapag yun ay maximal, yung quotient ring na to ay field. Pag-aralan natin last time. Therefore, what do we have? If you have field f, polynomial f of x, which is irreducible over f, magko-follow kasi na yung ideal na to ay maximal. So therefore, it follows that this is a field. Sure tayo dyan. Basta ito ay irreducible. Kaya natin target makahanap ng mga irreducible polynomials kasi they will help us construct a field out of the polynomials. Yan, ayun. Ito yung proof. Oh, look at this. Kung si f of x ay irreducible, sabi natin kanina ito ay field. Okay? E di ba lahat ng field ay integral domain? Diba? Pero ang hindi totoo yung pabalik. Yung pabalik ang hindi totoo. Lahat ng field ay integral domain, walang zero divisors. Eh kapag ang quotient ring naman integral domain, anong magko-follow? Yung ideal na yan ay prime. Kaya kapag si f of x ay irreducible, it generates a prime ideal. Meaning to say, it's also a prime polynomial. What does that say? Ito yung sinasabi nun. Pag irreducible si f of x at dinidivide niya ang product ng dalawang polynomials, okay? Dapat isa dun sa mga factors ang dinidivide ni f of x, parang property yan ng mga prime number, di ba? Halimbawa, nakakita ka ng, let's say, halimbawa, nakita mo na natuklasan mo si 3, dinidivide niya kunwari si 18, natuklasan mo. Sabi nung pagiging prime ni 3, kapag ifa-factor mo si 18 in any way, let's say 9 times 2, dapat isa dito sa mga factors ang divisible sa 3. Yun ang ibig sabihin natin ng prime. Okay? So therefore, we have the following corollary. Every irreducible polynomial is also prime. Ang di totoo, kapag prime, hindi ibig sabihin nun irreducible. No, there are rings in general where prime elements are not necessarily irreducible. Kasi nga, yung reversal nung yung reversal nung arrow na to cannot be guaranteed. Hindi lahat kasi ng field, hindi lahat kasi ng integral domain ay field. So, please be careful on that. All right. So what's this? So here I have the polynomial x squared plus x plus 1. Prove that f of x is irreducible over z sub 2. Construct addition and multiplication tables for the field E, which is the quotient ring z2 square bracket x modulo the ideal generated by f of x. Then also show that E has an element row which is a root of f. Kasi yung element na yun, pag ini-square mo, in-add mo sa row, nag-add ka ng 1, lalabas ay 0. So parang yung example na to, parang tinuturuan ko yung sabi, may polynomial ka irreducible, so wala siyang root. No? Diba? Pero nakagawa ka ng field kung saan sa field na yun, meron kang root. That's a very nice thing na that we have achieved for today. Okay, let us see. Buti na lang, quadratic lang ito. So medyo madaling ipakita na irreducible siya. You just need to show that it doesn't have a root. Na? Okay. So over z sub 2, what do we have? If I evaluate f at 0, you see that this is 1. F of 1 is also 1. So therefore, f has no root in z sub 2. And since, please mute your microphones when not in use. Can you please check your microphones? Naka-on yata. Microphones. Okay. Since degree of f is 2, no? Magpa-follow na si f of x is irreducible. Madali yung una, no? Okay. Now, we are now going to form the field E, which contains the cosets of this ideal. So, ganito yan. Tuturuan ko kayo, ha? Tawagin muna natin I para mas maikli yung ideal generated by this. Anong laman nito? Ang laman nito yung mga multiples ng x squared plus x plus 1. Question, what are the elements of this quotient ring? No? So, remember, ang Z2, ang Z2 square bracket x modulo this polynomial, modulo I, consists of all polynomials of the form f of x plus I, hindi polynomials. Ang laman yan mga cosets, where f of x is in Z2 square bracket x. But by division algorithm, do you remember? But by division algorithm, we may express, we can divide f of x by x squared plus 1. Magkakaroon ka ng quotient, magkakaroon ka ng remainder. Ang remainder mo, ang degree, 1 pababa. Kaya dapat ang remainder mo ang itsura ax plus b, no? Where a and b are elements of z sub 2, so that, kita nyo, no? Yung f of x, magiging congruent siya sa ax plus b modulo I. Ba't congruent? Kasi kapag sinubtract mo itong dalawa, ang maiiwanan ay multiple ng q of x. Ay, ng x squared plus x plus 1, sorry. Lahat ng multiples ng x squared plus x plus 1 ay nasa I. Kaya yung dalawang element na to, they are congruent. Meaning to say, lahat ng elements ng E are expressible in the form ax plus b plus I, where a and b are elements of z sub 2. Yan ang mga nandiyan sa E. Ilang choices ba meron sa A at saka sa B? Tigalawa, 0 or 1. So by the fundamental counting principles, meron kang 2 times 2 or 4 cosets that are in E. In fact, we can list them down now. No? Ano-ano yung mga elements niyan? Diba, pag parehas 0 yung A and B, what do we have? 0 plus I. Diba? Pag, let's say, 1 naman ang B, 0 ang A, you get 1 plus I. Pag naman 1 ang A, 0 ang B, you get x plus I. No? Kapag naman parehas 1 si A at si B, you get x plus 1 plus I. Okay? Wala. Eto, para lang mas mapaikli yung notation, denote yung 0 plus I, dahil siya yung 0 nung ring na ito, isusulat ko na lang siya na 0. Okay, for short. Tapos yung 1 plus I, dahil siya yung unity ng ring na ito, I will just write it as simply as 1. Tapos yung x plus 1, I will denote it as row. Yung x plus I, sorry. Yung x plus I will just denote it by row. So that the other elements are yung x plus 1 plus I kasi na ito is the sum, remember, of x plus I plus 1 plus I. So, pwede ko ito isulat ng row plus 1, no? As in my notation. Okay? Here, so ano na mangyayari? Wait lang ha. Kakopy ko yung page. Alright. So, magdi-delete ako dito ng portion. May di-delete ko. Dito na tayo eh. Sige, di-delete ko to. Delete. And then I'm going to put it here. So we have more space. Even more space. Deletein ko. Okay. So that's it. So pwede natin isulat ngayon daw yung mga elements ng E ng ganito. 0, 1, row, tsaka ano? Row plus 1. Yan yung mga elements ng E. Okay? Sino yung 0? Yung 0 ito. Yung 1, ito yon. Yung row, yun yung x plus I. Yung row plus 1, yun yung x plus 1 plus I. So, this is just a shorthand. Kasi remember, gagawa tayo ng addition and multiplication tables. Ayokong maglagay ng mga plus I pa ulit-ulit para maliit lang yung table natin. Mamaya na natin gawin yung table. Meron, sabi yan eh, also show that E has an element row so that row squared plus row plus 1 equals 0. Now, hindi nagkataon na ito yung tinawag ko na row. Kasi in fact, siya yung magiging root ng polynomial na yun. Tignan nyo ha. Notice that yung row squared plus row plus 1 actually is x plus I squared, x plus I plus 1 plus I. Yan talaga ang meaning niya. Diba? Pag simplify mo ito using coset operations, magiging ano to eh, x squared plus I, x plus I, 1 plus I. Paano ba tayo nag-add ng cosets? We do it representative wise. So, ang mangyayari, magiging x squared plus x plus 1 plus I. But, yung x squared plus x plus 1 kasi, nandyan yan sa I. Diba? Right? Yung 0, nasa I din. Kasi ang I ideal, so 0 is in there. So therefore, pag pareho silang nasa same ideal, they are congruent modulo I. Kaya yung x squared plus x plus 1 mo is congruent to 0. No? Ang x squared, lagay ko dito ha, is congruent to 0 modulo I. Kaya kung congruent sila, modulo I, ibig sabihin yung mga cosets na gine-generate nila ay parehas. So, ibig sabihin, parehas to sa 0 plus I or simply 0. So, what do we have? We were able to get an element in this field, namely row, na pag sinubstitute mo dun sa F, no, nagiging 0. So, therefore, we can say that row is a root in E. Now, this is to explain of f of x. Yung f of x na yan, wala siyang root sa z sub 2, pero meron siyang root na naroroon sa E. You see that? Gawin nga natin yung addition and multiplication table ng E. Paano yun? Paano tayo nag-add? Paano tayo nag-subtract? O, addition muna. 0, 1, row plus 1. 0, 1, row plus 1. Okay. So of course, 0 to. So, walang mangyayaring maganda dyan. Interesting, no? Anong 1 plus 1? Remember yung 1 na ito, we're working as if they are in Z sub 2. Anong 1 plus 1? 0. 1 plus rho, that's rho plus 1. Anong 1 plus rho plus 1? O, ano to? Modulo 2 to. Kaya ito ay rho lang. Nakuha nyo? Do you understand? Rho plus 1. Siyempre, rho plus 1. Rho plus rho. Anong rho plus rho? Sige nga, anong rho plus rho? Ano ang rho plus rho? 2 rho. Pero ang 2 mo sa Z sub 2 ay 0. Kaya ito ay 0. You see? Huh? Do you see that? Okay. Oh. Ano naman yung rho plus 1? Rho plus rho is 0. So therefore, this is 1. Rho plus 1 plus 1. Rho na lang. Rho plus 1 plus rho, 1. Rho plus 1 plus rho plus 1, 0. So this is the addition table. So let me just, ayusin ko lang. Sa notebook nyo, pakiayos na lang para mas maganda. Okay? Paano ang multiplication table? Pag multiplication table, lakihan ko ha. Okay. Siyempre, yung sa part nung sa 0, tsaka sa 1, trivial yun. No? 0 lang ito. Ito, kukopyahin mo lang kasi unity yan. Di ba? Ano ang rho times rho? Ano yung rho times rho? Rho times rho is of course rho squared. Di ba? Ang rho times rho is rho squared. Kaya lang, walang rho squared dito. Saan kaya equal yung rho squared dyan? Alam niyo kung saan? Bakit ito parehas sa may, di ba? Tignan nyo. Oops. Wait lang. Ito matawag. Basic na yan. Di ba ang rho squared plus rho plus 1 ay 0? So anong rho squared? Minus rho minus 1. Kaya lang tayo ay nasa Z sub 2, kaya ang negative 1 ay 1 lang din. Kaya parehas lang ito sa rho plus 1. Do you understand? Do you understand me? Paano naging rho plus 1 yung rho squared? Kasi nga ang rho squared plus rho plus 1 ay 0. Ang rho squared ay minus rho minus 1. But minus 1 and minus 1 are both 1 in Z sub 2. Sige nga, gawin nyo nga yung rho times rho plus 1. Ano ang rho times rho plus 1? Magiging ano to? Rho squared plus rho. But take note that rho squared plus rho plus 1 is 0. So anong rho squared plus rho? Negative 1. Pero ang negative 1 ay 1. Kaya ito ay 1. 1 din ito. Commutative ring kasi yan. Tapos, ano yung rho plus 1 quantity squared? Sige nga. Rho plus 1 quantity squared. Scratch tayo. Sige, scratch tayo. Rho plus 1 quantity squared. Meron tayong freshman's dream theorem. You can, kasi mo, characteristic 2 tayo. You can apply. Okay? Or kung, let's say, hindi mo gagamitin yung freshman's dream theorem, fine. You can just do it manually. Let's say, nakalimutan mo yun. Oh, that's okay as well. Rho plus 1. Ganyan siya, di ba? Pag in-expand. Ang rho plus rho, 0 yan. Kasi 2 rho. 2, 0 yan, di ba? So, you get rho squared plus 1. Now, remember, tatandaan nyo palagi yung identity na to. So, anong rho squared plus 1? Ang rho squared plus 1 is minus rho. But negative 1 is just 1. Kaya ang sagot dito ay rho. So, ang rho plus 1 quantity squared ay rho. So, ito finally ay rho. Oh, do you see that this is a field? Look at the table. This should be a field kasi sabi ng theorem natin, this must be a field. Ay, my gosh. This must be a field. Siguro ang kaduda-duda lang naman dito yung kung, di ba pag field, dapat lahat ng non-zero elements unit. So, ganito nyo i-check yun. Burahin nyo yung zero. Hindi kasali yun sa usapan. Check nyo kung lahat ay may multiplicative inverse. So, syempre, si 1, ang multiplicative inverse niya, si 1 sarili niya. So, check. 0, sinong multiplicative inverse? Kailan siya mag-1? Ayun, no? Nasagot, rho plus 1. Kaya dito, ang rho inverse ay rho plus 1. Do you understand? In this field, ang rho inverse ay rho plus 1. And mag-follow na ngayon ng rho plus 1 inverse is also rho. Kasi dito titignan nyo. Diba? So nakita nyo, lahat ng mga non-zero elements ay what? Lahat ng mga non-zero elements ay may multiplicative inverse, which confirms the theorem. No? Kasi sabi ng theorem, yung E daw na ito, na ang laman ay mga cosets. Mga cosets yan. No? Gumamit lang ako ng ibang notation so that you can actually see that it's really a field. Normally, ganito itsura nila. Ang pangit, no? I don't like to write cosets this way kasi hindi nyo makikita na, mahirap makita na siya ay field. Kung nakaganitong form ng may plus I. Did you understand this example? Oh, babalikan ko. I-screenshot nyo so you can take notes. Ito yung unang page. Ito yung pangalawang page. Okay? Okay. Actually, ito yung main idea. Ito yung nagsasummarize ng lahat. Pag irreducible si f of x over f, makakahanap ka ng field na E prime containing a subfield f prime isomorphic to f and an element rho in E prime which is a root for f. Ang gagawin nyo lang, i-generate nyo ulit yung ideal na nag-generate ng f of x. Pagkatapos bubuin yung quotient ring na ito, which is going to be a field, yun yung tatawagin yung E prime. No? Paano nyo malalaman yung f prime na subring isomorphic to f? Kunin nyo yung mga ideals, mga cosets ng I that contains the elements of f, yung mga a plus I, where a is in f. So technically, ang isomorphism ng f tsaka ng f prime ay ito. Pag may element ka ng f, ina-associate mo siya doon sa coset na a plus I. Kaya yan isomorphic sa f. So sino yung nagiging root? Sino yung nagiging root? Kagaya doon sa example ko, ang kukunin yung rho ay si x plus I. Tingnan nyo, balikan natin yung example ko. Ang ginawa kong rho ay si x plus I. Siya yung gumana na root. Yung ideal generated, the coset that contains x. Ito yung palaging magiging root. Yan yung sikretong ingredient siya. Yan yung formula sa root, x plus the ideal. Nakita nyo, ang ginagawa natin na nakakapag-generate tayo ng field na magko-contain sa root, na magkakaroon ng root para dun sa irreducible polynomial lang hindi natin kailangan mag-imbento ng panibagong number system. No? Anong ginagawa natin? Ang ginagawa natin is all valid and legal. We're considering cosets and quotient rings. Yung quotient rings ang nag-aalaw sa atin na gumawa niyan. So ito yung picture. Ito yung F. Ito yung binuo nating quotient ring. Ang laman nito mga cosets. Mahirap siya. This is a very abstract concept, but this is how we do it in abstract algebra. Tapos, meron siyang subring na F prime. Isomorphic ito sa F. Ito yung isomorphism. So, para mong sinasabi na, ayan, kapag si f of x ay walang root sa f, no? Has no roots in f, then pwedeng somehow, kasi kung kamukha ito ng f prime, dapat si e prime may kamukha dito na kino-contain si f. Yun yung i-confirm natin sa next lesson. Talaga bang merong e na nasa taas ng f, no? Nakamukha nung e prime na yon? Talaga bang merong ganon? Ayun, yun yung ating susunod na lesson. Paano mo malalaman yung e? Parang halimbawa, I can take, for example, the set R of real numbers, and I can take the polynomial x squared plus 1. I know that this is, well, an irreducible polynomial over R. Wala itong root sa R. Pero I can construct a field containing cosets, no, that will have a root for x squared plus 1. Sino yung field na yun? Ang sagot, r square bracket x modulo x squared plus 1. Lagi nyo nakikita ito. Diba? Lagi nyo nakikita yan. Ito, meron tong element, ang pangalan x plus I. Yung x plus I na yan, pag inano nyo, pag in-square nyo, tapos mag-add ka ng 1 plus I, anong lalabas? Which is congruent to 0, kaya ito yung 0 plus I. Nakita nyo? Kung tatawagin mong row ito, parang sinasabi mo row squared plus 1 equals 0. So nakahanap ka ng element na root ng f of r, ng f of x na wala sa r. In fact, nandito. Pero naalala nyo last meeting when we were talking about homomorphisms, nalaman nyo na itong field na ito actually is isomorphic to C. We did this. Kaya sa case nun, ito yung C. Na makakahanap ka ng field larger than F na merong root yung polynomial. Do you see that? This is a very abstract concept. Sa umpisa, para kang masusuka. Parang ang hirap tanggapin ng laman loob mo. Pero eventually, kayo ay masasanay kasi this is how we do things in abstract algebra. No? Kumbaga, hindi pa pwede sa abstract algebra yung sasabihin mo, ay sige, mag-invento tayo ng symbol na I. Tapos yung I na yan, iisipin natin root siya ng I squared plus 1 equals 0. That's kind of absurd, di ba? In fact, talagang mang historically absurd yung ginawa ni Gauss. Di ba si Gauss yung nag-invento ng mga complex numbers, yung 1 plus I, ay yung mga ganyan, no? Yung I. Weird kasi yung square root of negative 1. Kung weird siya, ba't mo siya ginagamit in the first place? Ang ginagawa ng abstract algebra, yung weirdness o yung absurdity ng mga complex numbers na ito, yung existence nila, kahit na sila weird, gina-justify siya using sound mathematics. Ano yung sound mathematics? Ito. Kaya meron tayong ring theory or field theory or whatever. Did you understand? Yung construction natin na yan ng number system pataas, no? But possible mag-construct ng ganyan is gina-justify ng mga theorems natin na pinag-aaralan dito. Did you understand me? Did you understand me? Naintindihan ba? Before I proceed to the next slides. So meron pa tayong isang problema actually. Kaya nating i-construct ito. Ang tanong, ito. Kasi ito yung directly above F. Diba? Siya yung nagko-contain kay F. Ito kasing field na ginagawa natin, hindi niya subset si F. Hindi niya subset si F. Meron lang siyang subset na kahawig ni F. Pero we do not actually mean na ito ay kino-contain si F as a subset. Meron siyang subset na isomorphic sa F. Yun yung truth. Kaya lang natin ina-assume na possibly merong field na nagko-contain sa F na may root yung polynomial mo na walang root. No? Ang tanong, lagi bang merong ganyan? That's the next question. Now, in order to talk about this field, we need to talk about some linear algebra. No? But before, so this lesson is about fields and their extensions. Ang tawag dun sa mga fields na yung mga fields, di ba? Ang mga field may subfield. Hindi tayo bababa. Tayo ay aakyat. Mula sa isang field, maghahanap tayo ng field na mas malaki that contains the given field. So that's what we are going to do. Okay? And hopefully, yung field na magagawa natin, which is bigger than or which is the extension of the given field, will contain a root for a certain polynomial that we are interested in. So that's what we wanted to do. That's our goal in this lesson. We want to describe that field. Okay, so magkakaroon muna tayong short break kasi ako'y naihi. Ipopost ko muna yung recording. Mag-CR break lang ako, ha? Pause. Ayan. Thank you for reminding me, John Paulo. Ayan. Kaya yung mga wala, hindi nila mapapakinggan yung hugot doon. Okay. So we are recording now, no? Halimbawa, itong set na ito, kanina, linearly independent over Q, pero linearly dependent yan over R. You know why? Kasi for example, I could make a fancy value. For example, I can place, makakapag-isip ka na ng real number dyan sa mga blank na hindi lahat zero, pero magagawa kong zero yan. Alam niyo paano? O di gawin kong zero to, so may pag-asa pa ako sa dalawa. Ito gawin kong 1, tapos ito gawin kong negative square root of 2. Allowed na kasi ngayon yung negative square root of 2 to become a scalar dahil over R na tayo. Kaya ang linear independent, di ba zero yan? Tama ba si sir? Zero yan, no? Okay. So, ito yung sinasabi ko. Yung linear independence ay depende doon sa field na pinag-uusapan or yung field of scalars. Did you understand me? Kanina independent sila pero ngayon over the new field hindi na sila independent. Dependent na actually. Right? Okay. So let's give some more example. Halimbawa, when you look at C as a vector space over R, again, ito yung 1 tsaka yung I, they are actually linearly independent over R. Kasi pag si A and B are real numbers, and yung A times 1 plus B times I 0, that will imply na yung A plus B ay 0. So that will mean A and B are 0 because A and B has to be real numbers. Pero the same set, kanina independent siya over R. But it is linearly dependent over C. How does that happen? Kasi I can find a way for this sum to become 0 even without making these scalars 0. No? Paano? I can put a 1 here, then I can put a minus I over there. No? Diba? Kaya, siya ay independent over R, pero dependent siya over C. Did you understand that? Naintindihan niyo yung sinasabi ni sir? Ito yung mga examples na magmamatter sa atin. No? Hindi magmamatter yung mga vectors na pinag-usapan natin sa linear algebra noon. Okay ba? Uy. Okay. So, bakit ba natin nag-usapan ng independence? Kasi we want to talk about a basis for the vector space. And why would we want to talk about basis? because we want to describe dimensions of vector spaces. Okay? So, balikan natin. So let's say you get a vector space V over F. Okay? We say that a subset S is a spanning set for V if every V every vector from V is just a linear combination of the element. Ay, mali ito. Sorry. In S. No? Mali rin ito. Ano ba yan? Typo error, sorry. So, pakibago. A subset S of V is a spanning set for V if every element of V is just a linear combination of those that are in S. Anyway, alam niyo naman ito. Nasa linear algebra na tayo. So, it's nice to have a spanning set for V, no? Kasi normally, a spanning set is a small set, but it can describe every vector in the space. Kasi lahat ng nasa space, linear combination lang ng mga nasa S. As much as possible, we want S to be as small as possible. And how do we make S as small as possible? We want to make it independent para wala siyang redundant vector. So I hope you are getting refreshed with these ideas. Now, kapag yung spanning set mo ngayon, walang redundant vector, or in other words, independent siya, ang tawag doon ay basis. A basis is basically a minimal spanning set. Kumbaga, spanning set and the number of vectors in it is just the right amount to span the space. Okay? Makakainis naman to. Sige ha, ito ay V, ito ay S. Theorem, we will not prove this, but we have proven this in linear algebra before. That if you have, it is possible for a vector space to have more than one basis. But definitely, if you have two different bases for a vector space, what's common about this bases is are their cardinalities. When you say cardinality, it's the number of elements. So, halimbawa, yung classmate mo was able to produce a basis with 3 elements. Dapat lahat, kung tama yung basis na nakuha ng kaklase mo, dapat lahat ng iba pang basis na makukuha ng ibang mong classmate, dapat 3 lang din ang laman. Naintindihan niyo? Ganun ang ibig sabihin natin ito. Any two bases have the same cardinality. Yung same number na yun is what's important in linear algebra, no? Because it tells us something about the size of the space or the linear size of the space. That is what we call as the dimension. Parang sa linear algebra, the bigger the dimension is, the larger the set in terms of linearity. That's the idea. Again, V ito at ito ay S. Yan. If it is possible for you to get a finite basis for the vector space, we say that the vector space is finite dimensional, at yung number of elements in any basis is what we call as the dimension of the vector space. Okay? If on the other hand, one cannot find a finite basis for a vector space, marami tayong examples niyan dati, no? Hindi ka makakakuha ng finite na basis kasi nagre-require siya ng infinite na basis. Ang tawag sa space ay infinite dimensional. I hope this reminds you of important things from linear algebra. All right, so this is now our big picture. Actually, kanina ko ba binabanggit ito eh. If F is a field, no? If F is a field and this is irreducible, no? May kulang itong parenthesis na to ha. If the degree is greater than 1, syempre. Automatic kasi kapag pag linear, automatic may roots yun. Kasi you can solve linear equations in any field. So if f of x is irreducible over f, then you can find, we will show that you can construct actually a field which is an extension of f, no? Directly above f. Hindi yung nag-imbento tayo ng quotient rings, no? Yeah. So this extension is directly above f. It contains an element alpha, which is a root of f. So that's what we intend to prove in this lecture. So these are the questions that needs to be answered. How do we construct E? No? What is the smallest subfield of G? Subfield G of E. O ganito, no? Ulit. Ito si F. Ito si E. The idea is, si E, meron itong element na alpha. No? Yung alpha na to ay root nung given na irreducible na polynomial. Okay ba? Now, alam nyo kasi possible na yung field na mako-construct natin ay masyadong malaki. It can be too large to contain just the required roots for f. Magbibigay ako sa inyo ng example. Alam niyo yung set of complex number na merong I na nagko-contain sa R. Yung I na yan ay root ng x squared plus 1. Right? Yung root na I, ay yung number na I ay root ng x squared plus 1. Pero alam nyo, hindi nyo naman kailangan yung buong C to actually solve for x squared plus 1. Parang ano to eh. Wag na tayo dyan sa C. Mali pala to example ko. Sorry. Ganito na lang. Halimbawa, sa rational numbers tayo. We're looking at the polynomial x squared minus 2. Meron bang solution yung x squared minus, meron bang root yung x squared minus 2 sa Q? Yes or no? Meron bang rational root yung x squared minus 2? 1 or 0? Pakisagot sa chat box. Ang tanong ko, may rational root ba ang x squared minus 2? None. Very good, none. Kasi ang roots niyan talaga, based on your experience, are square root of 2 and minus square root of 2 and none of them is rational, right? Ang gagawin nyo, naturally, ang susunod na extension field ng Q na titignan nyo ay si R. Fortunately, si R ay may square root of 2 tsaka minus square root of 2 which serve as roots for x squared minus 2. Pero alam nyo ba na si R ay napakalaki? You may have overkilled the polynomial x squared minus 2 by using the entire real number line. Kasi this field is just too big to just address a very simple problem. Ang problem mo, x squared minus 2 lang. Pero ginamit mo yung buong real number line. That may be an overkill. Na? So kaya ang tanong natin dito, tignan nyo. What is the smallest subfield G of E that contains F and alpha? So sa context ng R tsaka ng Q, this is what we're going to do. Ano yung pinakamaliit na subfield ng R na just enough or just of the right size na magko-contain sa Q tsaka sa mga roots ng x squared minus 2? So I just want a field that is not too big. I just want a field that is just of the right size that will contain what? All the rational numbers, of course, and will contain the roots for x squared minus 2. Now, ano kaya yung field na yan? Ano kaya ito? This is what we actually want to find, yung G. Kailangan yung G hindi masyadong malaki. Alam niyo kung anong sagot? Ang sagot, ganito yung notation natin. Q square root of 2. Ang laman ng Q square root of 2 ay yung mga numbers na ganitong itsura where A and B are rational numbers. it turns out that this will form a field. Ang laman nito yung mga a plus b square root of 2 where a and b are rationals. Halimbawa, 1/2 plus 1 square root of 2. No? Malalaman nyo, this is just, halimbawa, yung square root of 3, wala yan dyan saan? Sa q square root of 2. Kasi alam nyo, hindi nyo naman kailangan ng square root of 3 to solve x squared minus 2. Ang kailangan mo lang square root of 2. Tsaka minus square root of 2. In fact, all you need is square root of 2. So you just want a field, parang ito si Q, ito si R, nandito yung square root of 2. So all I need is a field that contains Q and the element square root of 2, which is the smallest one. No, ayan yung G. Ito lang ang kailangan ko to solve this problem. Kasi by looking at R, that might be an overkill na masyadong malaki yung R. So ito yung interest natin dito. Question. How do the sizes of F and G compare? Halimbawa, how do we compare R with the size of this G? No? So definitely, mas maliit si G kay F. Kaya lang, paano natin i-compare yung sizes nila? So these are the questions. Piniphrase ko ng questions para sa inyo. No? Kasi, yeah. Yun lang yung, ito yung mga gagawin natin. Okay. Now, introduce ko muna sa inyo yung ibig ng subfield. Pag sinabi subfield, alam niyo naman ito. Subring lang siya na field lang din. Okay? And if you want to test if a subring is a subfield, you might need to do the following. Originally, ito lang yung test. Tatlo. So check nyo lang. Actually, ang originally, pag subring, ito lang ito-test nyo. Yung 0 dapat nasa G. Kapag yung A and B nasa G, dapat itong dalawa nasa G. Yan lang ang ite-test nyo kapag subring. Pero dahil we are testing for a subfield, i-check nyo na ngayon, may additional check na kayong gagawin. I-check nyo na rin kung yung unity ay nandoon sa G at kung closed man yung G under inversions. Kasi remember, yung mga non-zero elements ng F dapat unit. So dapat kung field si G, dapat yung mga non-zero elements niya rin ay may multiplicative inverse. Furthermore, we want their multiplicative inverses to fall inside G. Did you understand me? Ayan, ito yung tinatawag nating subfield test. Ayan, to formally define, if F is a field extension of F is just a field E which contains F as a subfield. The operations in the extension, the operations in F are basically the restrictions of the operations on E. Halimbawa, si C ay field extension of R. Now you can check that this is a field extension of Q. Ito yung sinasabi ko kaninang example. In fact, ito yung pinakamaliit na field na magko-contain saan? Sa rational numbers at saka sa number na square root of 2. How did you know, sir? How did we know? First of all, field ba talaga yan? No? Field ba talaga to? I-check nyo. Ano nyo i-check? Actually, ang kailangan nyo lang i-check dito yung closure for inverses eh. Yun lang eh. Halimbawa, ito hindi zero. Kunin nyo yung reciprocal niya. Nandyan pa rin ba siya sa E? Di ba sa algebra, paano nyo ginagawa ito? Sa algebra ang pangbata, paano nyo ginagawa ito? May ginagawa kayong kabalbalan na ganito, di ba? Yung multiply mo ng ganyan, ganyan. Ang purpose mo is to re-express the number in this form once again. Actually, ito yung proof na lahat ng mga numbers dito, basta hindi zero, may reciprocal na nandito ulit. Check mo. Check mo ulit. Magiging ganyan yan, oh. Tapos, a squared minus 2b squared. Pagkatapos, let me go here. Yung 1 over a plus b square root of 2, magiging ano siya? A over a squared minus 2b squared plus minus b over a squared minus 2b squared square root of 2. Magiging ganyan siya pag sinimplify. The idea is, because a and b are rational numbers, you look at these combinations, this will remain as rational numbers. Diba kapag naman nag-divide ng dalawang rational numbers, rational pa rin yun. Kaya nakakagarantiya tayo na ang reciprocal ng mga non-zero elements nito, nariyan pa rin. In fact, this contains the square root of 2. Gawin mong 0, tsaka 0 si A, 1 si B. Diba? And this contains what? This contains all the rational numbers. Gawin mo lang 0 si B, gawin mong arbitrary si A. No? Ano pa? In fact, nandito lahat ng mga bagay na pwede mong gawin sa square root of 2. Ano yung sabihin ni Sir nun? Pag kasi field, ang mga allowed operation, pwede kang mag-square, pwede kang mag-multiply, mag-add, pwede ka rin mag-divide kapag field. Basta ang pang-divide mo ay hindi 0. Lahat ng mga kailangan mo, no, para maging field, nandiyan. Okay? If E is a field extension of F, then E is a vector space over F, where, ito na nga, nabanggit ko na to kanina. Right? Alright. Ito na. If E is a field extension of F, so ganito tayo. So si E ay vector space over F. If it is possible, if it is possible to find a finite basis for E over F, ang tawag natin, so si E ay finite dimensional over F, ang tawag natin dito sa A, we call it a finite extension. So pag narinig niyo si Sir, E is a finite field extension of F. Ibig sabihin si E ay extension field, at the same time, finite ang kanyang basis over F. So meron siyang dimension na finite. Okay? Ang tawag natin dun sa dimension ni E over F, kung finite man yung extension na yan. Ito siya sa linear algebra. But in abstract algebra, we shall use this notation instead. Sa linear algebra, ganito sinusulat, pero in dimension na yan, it will be denoted by this bracket notation. Kasi you will see that this will be useful later. Ang tawag nyo dyan sa dimension na yan, you call it the degree of the extension. Kumbaga, pag nasa linear algebra ka, dimension ang tawag, pero pag nasa abstract algebra 2 ka, pinag-aaralan natin mga fields, ang tawag dyan sa degree or sa dimension na yan ay degree of the extension. May kinalaman ba yan, sir, sa degree ng polynomials? Yes. Okay, kaya degree ang ginagamit dyan. It has something to do with degrees of polynomials, as you will see, as we shall reveal later. Kapag ang degree, or kapag yung dimension na yan, kapag si E ay two-dimensional over F, we will call E a quadratic extension of F. Siyempre, kapag degree 3, we will call E a cubic extension of F, and so on. Na kapag 4, quartic extension, etc. Just one example, halimbawa, yung field of complex number. You know, the field of complex numbers is actually a quadratic extension of R. Alam niyo bakit? Can you give me a basis for C over R? Ito. Kasi sabi niyo lahat ng complex number pwedeng isulat as A times 1 plus B times I. At the same time, ito ay linearly independent over R. Diba? So basis siya. So dahil may dalawang elements in this basis, anong degree ng extension na ito? Ang degree ay 2. Did you get that? This is easy, no? Yan. Paano nyo iisipin ang vector space C over R? Ganyan. Ano ba yung 1, pwede mo isipin na ganyang vector. Si I, ganyan. Di ba? Ano ba, may vector kang 4 plus 3.5i. Sabihin yan, 4 na 1, tsaka 3.5 na i, pag nag-combine, yun yung 4 plus 3.5i, etc. No? Etc. Forever and ever. Okay? I think dahil 12:59 na, we shall just continue next meeting. Please don't be absent next meeting, as next meeting will be the last synchronous session for this semester. And also, i-stop na natin yung recording.